Greetings everyone. We're going to go ahead and get started. You know that this is your enrichment packet for section 8. We have already talked about the questions that you need to look over, although most of them are identical and they repeat. So let's get started. Number 1. ABCD is going to be a rhombus, whereas the measurement of angle DAC is going to be 3x minus 11, and the measurement of DAB is going to equal 4x plus 3. So right off the jump, we need to know some things about a rhombus. That line that's coming straight down the middle, A to C, that's going to be our diagonal. That diagonal AC acts as an angle bisector. So before we do anything, let's first go ahead and mark that DAC, which is here. Okay, so remember from our studies that DAC is going to be equal to 3x, and this is in your rhombus notes, and it's an example just like this one in the rhombus notes, 3x minus 11. Now remember we said it acts as an angle bisector, so it cuts it in half. That means that the other side is exactly the same amount. So we don't know what the number is yet, but we will find out. We know what the expression is. The expression should be 3x minus 11. Now, that angle can be named angle BAC or CAB. It really doesn't matter. It's totally left up to you. But from here, we need to keep going. I cannot set up an equation with these two only. I need to make sure that I set up an equation that's going to have, of course, an equal sign and equal to the whole thing. So remember the whole angle DAB, which is here. I'm just going to go ahead and do like this, is going to be equal to 4x plus 2. Okay, so essentially what we're going to be looking at is the angle DAC plus the angle, remember, BAC right next to it, should equal or does equal angle DAB, the whole thing. Okay, so here we're going to end up with 3x minus 11 plus 3x minus 11. Okay, from right here. And then all of that is going to equal 4x plus 2. Now remember, for whatever reason, you guys don't get lost in the sauce. 3 and 3 is going to give you 6. I had quite a few people write 9. I think in your mind you were doing the multiplication, and that's okay. Mistakes happen, but we can fix them. Now after the test, it is what it is. At this point in time, just like in your regular algebra, you can move any of these. It doesn't matter. I'm going to choose to subtract the 2. But you didn't have to do that. And as long as you do your math work correctly, you'll get the same exact answer. Okay. Only thing we can move at this time is the 6x. Remember, you always follow your inverse operation. Opposite of multiplication is division. Why'd y'all let me write this 6 right here? That's a 2. See what I mean by mistakes? So now that we have that 2, that cancels out like that. And then the negative 2 divided into the negative 24, of course, is going to give us a positive 12. So x is going to equal 12. Now that we have that, the second thing asks us, what is the measurement of angle ABC? We've got to identify angle ABC. Angle ABC is here, A, B, C. Remember, the most important letter is going to be your vertex, which is here. So this is going to be angle ABC. There's a special relationship in a rhombus between these two angles. They are next to each other. They are back to back. These are our consecutive angles. Remember, your consecutive angles are going to be supplementary. So that means that angle DAB, I'm going to write up here, plus angle ABC is going to be equal to 180 degrees. Now at this time we don't know how much DAB is going to be, but we can solve for that quickly. It doesn't take long, and I'll use this space up here to do it. Alright, and so angle DAB is going to be equal to 4x plus 2. All we're doing is replacing the value here and adding 2. So of course we should see that that's going to be 48 and then plus 2. So we know that DAB is going to be 50. So over here we know that that's 50 plus angle ABC equals 180. We simply subtract the 50. And then of course this is going to get us to 130. And that's number 1. Number 2 is designed the same exact way. So if you could do number 1, then you should be able to also do number 2, asking the same exact thing. Okay? Alright, so now remember, and let me show you in this one so that you don't think that I'm lying to you. In question number 2, it asks DAC. Remember, DAC is going to be located here. My bad. We're looking at ADC, so that's going to be this angle here. This angle and this angle with DAB are still going to be supplementary, equal to 180. Okay? All right. In the next question, it asks us about the measurement of angle B, which I'm going to go ahead and mark, and the measurement of angle C. There's no math that needs to be done right here. This is just knowing your background information. So this gives us a rhombus. It tells us which statement explains why the equation 7x minus 10 plus 2x plus 5 equals 180 can be used to solve for this. Now we already know, because we just covered that these two angles are they are supplementary, which means that they add up to 180 degrees, and that's the equation that's right here. Now the reason that that works is because it is indeed a parallelogram. So I'm going to cut this like this. And BC would act as the transversal. Because this acts as the transversal, this angle here, B, and this angle C, is going to be what we call same side consecutive angles. So remember when we studied that earlier in the year, same side consecutive angles are supplementary. What makes that happen? Our parallel lines. Okay? So, opposite sides in a rhombus are parallel, and that's what we checked. Done. Question number 5 is one of my faves. It's a proof. No need to dread over the proof. We just need to make sure that we are paying attention to what we are doing when we are doing the proof. Remember, when we read, everything is essentially the step ahead of it, and it's pretty much telling us what it wants us to do. So you want to read the statement, apply the statement to the picture if you can, and then keep going. So now looking at the very first one, it says statement ABCD is a parallelogram. And when we look up here at the top, well, there it is. ABCD is a parallelogram. And look where it's written, right there next to given, which is one of your answer choices, so you write given. Okay. We then look and see that AD, so AD is here. The sign in the middle means parallel, so we put our parallel markings on it. Now, if you don't want to, I'm not really going to pressure you, because the picture can get a little junky with all the markings on it, but it's still important so that we know. All right, and then AB, I'll put 2 on here because it represents a whole separate set of lines. Those two are going to be parallel. I'm sorry about those arrows. They are raggedy. So remember, I always told you need to look back at the statement above. Well, the statement above clearly tells us that this is a parallelogram. So the reason why these two sides are parallel is because the definition of parallelograms. So that's the third one right here. So that's what we're going to put right here, definition of parallelogram. All right, it's a little tiny space, so we'll go with that. But you have your paper, so you can see what I'm talking about. All right. The third statement tells us that angle ADB, remember the most important letter being in the middle, but you still have to trace it. So here we go. We've got angle ADB. So notice where I traced. That's this little piece right here. Remember, you don't want to go further because we didn't say anything about C. We went up to B. All right, those lines should always be touched. And then the next one is angle DBC. So we start off at D, travel up to B, and then down to C, which is here. So I'll put a little marking there, just like that. Okay. And we go straight to the next one, which is angle ABD. So we find that angle ABD. So this angle here, I'm going to put 2 markings on it. Okay, 2 markings. And then we're going to angle B. Where am I? Yes, BDC. And so that's 2 markings on this one as well. Okay. Now they ask us, of course, why are these 2 parallel? Now we have to, congruent. Remember, we have to remember that these are parallel lines cut by a transversal. Notice the transversal is very faint, but I'm going to just darken it and come right on through. Come through, transversal. All right, so now that the transversal is there, we should be able to see that these are on the inside of the parallel lines, but the congruent angles are on opposite sides of the transversal. So that should lead us to know that this is if 2 lines are parallel and they are cut by a transversal, then we know that alternate interior angles are congruent. So this is alternate interior angles. Okay, so remember, when you look for that, it's going to start off with that long sentence. If 2 parallel lines are cut by a transversal. Okay, that's how it's going to start off. But what we're looking for is the alternate interior angles. Okay, we've got them nice and marked in our picture, so we're good to go. Now this should be everybody's favorite one. Everybody, whenever you see this, should know exactly what it is. When we see something is equal to exactly itself, right away we should know that that's the reflexive property. We shouldn't even wait or hesitate. By now we should know that. So reflexive property is here. That's the DB. That's congruent to DB. Same line. So right down here, that's what we're going to put, just reflexive. Now when you look at your answer choices, the answer choices say, trying to get to this ahead of time. Reflexive property of congruency. Same thing as just putting reflexive. We just have a limited amount of room. So remember, immediately we need to look at the picture and determine, picture, what are you saying to us? So it's asking us in the very last one, triangle BCD should be congruent to triangle DAB. Now, why should they be congruent to each other? Well, good question. Let's check that out. I'm going to use this notebook and kind of just hide one of them. That's everything. So that you can kind of see what I am looking at. So what we're looking at is this one angle marking here that we put down here at the bottom. Okay, this one side marking in the middle, and then this angle marking over here. So when you look at your answer choices, they're giving you 3 answer choices to choose from: side, 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 angle, side, angle, 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 side. This is clearly angle, side included in the middle, and angle. So ASA. Okay. And just like we have answer choices here, you'll have answer choices on the exam. In order to be successful on this one here, you've got to know how to read the angles. The angles are read, of course, you guys, by, of course, the letter in the middle, but also knowing how to bind them by the 2 letters on the outside. So we're looking at DCE, DCE. So we're going D, C to E. right here, which is 63. Okay. And then we're looking at DAB, which is here, 115. There are so many ways that you can break off and get ready to do the work, but it doesn't matter. You get to decide what you want to do. So let's start off with some parallelogram rules. So we know that in a parallelogram, opposite angles are congruent. So if I know how much this angle is, the opposite angle, which is all of this angle here, angle DCB, is equal to 115. For me to find this little piece right here, I just need to do a little piece of math. I need to take that 115 and I need to subtract what's already there, which is the 63. Okay. So with our 52, we just fill that in here or write it here. It doesn't really matter where you're going to put it. You just need to put it somewhere. So I'm going to fill it in right here. And that's one angle already filled in, done. Notice I didn't go down here and do anything. I'm filling in everything up here before I move down here. Okay. So in this one here, we've got E, we've got 63, and oh my goodness, we've got an angle over here. Listen, you guys, that's a triangle. And we know all day, every day, that the sum of a triangle equals 180 degrees. Okay, so that means that these three angles, 90 plus 63 plus x, equals 180. Okay. So even if you didn't do that, since this is already 90, we know that we're looking for a number that adds to this number that would give us 90 as well. So once you do that calculation, we should all be at 27. Okay, so we know that this is 27. And we're good. We've got one whole triangle filled in. We've got a couple of angles to go, but it's worth it. Then once we finish, we can actually look and see what we're doing next, okay? All right, so then in the next one here, this little triangle, it should be easy for us to figure out that, oh my goodness, 90 degrees. If this is 90 degrees and on the other side of that, those two angles will be what we call linear pairs. It also should be 90 degrees because linear pairs add up to 180. So the same work that we just did, we're going to do over here. Okay. You can call that y if you want to. It really doesn't matter. You don't have to call it a variable. But it just helps. So when you're going back in and filling it in, you know what you're talking about. So 90 plus the 52. And again, I call that y is going to equal 180. And again, if you know some just quick math, we know that we are looking for the number added to 52. That will also give us 90. Or you can do it all together. It really doesn't matter. Excuse me. Okay, so we should all be able to come up with the same number, and everybody should, of course, have 38. So in our parallelogram notes, what we learned is that this line, that diagonal, acts as the perpendicular bisector. Sorry, my goodness gracious, scratch that. What we know is that this line acts as the transversal when we have parallel lines cut by a transversal. So since this is a transversal, we know that the alternate interior angle is going to be the same. So remember, that's going to be on the other side. So if this is 27, I know that this over here is 27. And if this is 38, then I know that this over here is 38. Okay, so I fill in all the angles possible to be able to answer this word. Now it's asking me, what is the measure of angle EDC? So when I look at the picture EDC, we got to trace that. So starting off with E, I'm going all the way out to D, and then I'm going to go down to C. So the angle that they are looking for is here. Okay, so 27. Then I'm looking at CBE next. So starting off at C, going all the way up to B, and then over to E. So that angle is right here, and that angle is 38. And here's an easy one. They are looking for BEC, so starting off at B, traveling to E, and then dropping down to C. So that means we're looking at angle E, which has a 90-degree box. And it's 90, just like that. Done and done. Question number 8 talks about the diagonal of a rhombus. So we've got a rhombus this time and talking about a diagonal. Remember, we did this in our notes when we did the graphing, and I told you that you needed to create yourself an X and a Y. Okay, so the X and the Y axis is really easy to make. Bam. Bam. Sometimes I label it wrong, but let's make sure we get this Y and get it X. Okay, we've got it. And then we're just going to graph the line that they gave us initially in the equation. So it says the equation for the diagonal is X equals -3. Okay, and there's your X equals -3, just like that. Remember, we went back to our notes to study how our diagonals must cross. Remember, not only do the diagonals need to intersect each other, but they need to form a 90-degree angle. And the only way we can form a 90-degree angle, of course, is if it's moving left to right, since the initial line is up and down. So remember, that's your undefined slope and your zero slope. That's going to give you these perpendicular or right angles. Okay, so if we test X equals -7, we know that's not going to work. 4, 6, 7, because it's going to be parallel. So that doesn't work. When we test Y equals -5, okay, 1, 2, 3, 4, 5. Okay. Indeed, it does work. So we know that B can be an answer. When we test Y equals X plus 3, remember we have to start off up at 3. 1, 2, 3. And because our slope is positive, or 1 over, let me make these lines too. A 1 over 1, we're going to go from here, go up 1 over 1, up 1 over 1, up 1 over 1 to make our slope. So does this intersect? It does intersect. But does it make a right angle with this? It does not. So it cannot be an answer. Before you do this one, you actually have to do some work. You need to put it in the format. So we're going to do X equals 3 minus Y. So we'll go ahead and do this. Add the Y to the other side. So that's going to give us Y plus X equals 3. And then, of course, get rid of that X. So then we'll have Y equals -X plus 3. So we'll be doing the same exact thing, but going in a different direction for the slope. How do we know that? Because it's going to be negative. So we're going to go up to 3. 1, 2, 3. And this time we're going to go down 1 and over 1. Down 1 over 1. And it's going to produce a whole nother line. Down 1 over 1. And hopefully all of this should be sounding familiar because this is the algebra part. Graph this line here. As you can see, it doesn't work. It does intersect, but it does not make a 90-degree angle. So that's out. And then our last answer choice, 1, 2, 3, 4, 5, 6. It does indeed cross and also make perpendicular, so we're good to go with E. It is always a good idea to test it just to make sure that you're not making a mistake. But if you can just remember that you're looking for your opposite of whatever it is. So if you got the zero slope, you're looking for the undefined slope. If you get the undefined slope, you're looking for the zero. So you're looking for x equals something. If it's y, if it's x, then you're looking for y equals something. Just a number, nothing else. Okay? I'm going to show you how to do this just so that it's on record. But remember, on the test, you're going to have multiple choice, and this is the question in which you need to run the slope formula for. Okay, so let's go ahead and graph our m. So this is the second method that I'm going to show you just so you can see it. We'll graph our m, and our m is going to be at -1, -1, -3. 1, 2, 3. And then, of course, our k is going to be at -4, 1, 2, 3, 4, and then up to 2, 1, 2. And here we go. Just like that. All right. Ta-da! Now that I have the line, what I need to do is find the midpoint of the line. So I'm going to show you how to do that. If you get lost in the sauce and this is not the method for you, and that's okay, because again, you'll have your answer choices, so you'll need to find the slope. And then after you find the slope of the line, of course, then you're going to need to do the inverse or the negative reciprocal. And then that's what you're going to be looking for when you test the slope of the answer choices. So one of these two methods will work, and we'll start off with one and end up with the other. So here is what I'm going to draw, and I don't have a pencil with me to erase. Hold on, let me see if I can find the pencil. Let me hit pause. All right, I'm back. Won't it really? I found a pencil. Okay, so here we go. We're going to go out to the side just like that. 1, 2, 3. What we're trying to do is connect it with this one here. 1, 2, 3, 4, 5. So the length of this up here is going to be 3. Okay, and the length over here is going to be 5, and I hope you can see the boxes and where it counted at 5. Remember, I told you I need the midpoint. So midpoint is the halfway point. So I need halfway of 3. Halfway of 3 is 1.5, which is going to put me right here, 1.5 boxes. And then, of course, half of 2 is going to be 2.5, which is going to put me 2.5 boxes. 1 box, 2 box. Here's my half. Okay, now this is how you do this if you do not have a graph. Where does this meet on the line? Because I'm looking at the midpoint of the line. It's right here. That's right there. Okay. All right. Now, I did that in the pencil so I can go ahead and get rid of that so that when I get ready to do my pinwheel, I won't have so much stuff on the page. Okay, so here we go. Here's the pinwheel that I'm going to create. What I am going to do is I need to travel up and over, and then I need to travel down. Come on, go straight down. Down and over. Notice when I drew this, I went up a half, that little piece of a half, and then 2. Remember, we said the halfway point was 2.5, and then I went a half and then 1, and remember the halfway point of that 3 was 1.5. I did the same thing below. So let me spin my graph so I can show you where this ends up. Here this is. So any direction you go, I'm going to turn this way. So for me to graph, the next thing I know I need to go to the right 2.5 and then up 1.5. So I'm going to turn the paper back and I'm going to show you exactly what we're going to do. So again, remember that was 2.5. So remember this is a half. Here is my 1. Okay, and then here's the 2. So that's 2.5, and then I'm going to go up a half and then go up 1. So my new point is going to be located right here. When I read that point is going to read as 0, comma, 1. Okay, I'll do the same thing with this one here. Again, I'm going to turn the picture. So this tells me this time when I go out to the left, I need to go out to the left excuse me, 2.5, and I need to drop down 1.5. So that's to the left and down. Okay, so I'm going to spin this back. To the left, I'm going 2.5 again. So first take the half, because that's what's there, and then 1, 2, and then take the half, and then 1. Okay, so in this one, this point is going to read as, remember, always start off with 0 and count. 1, 2, 3, 4, 5. So that's going to be 5, and then we went down 1, 2. That's a -5, please forgive me. And then we go down to -2. Okay, that makes the other diagonal, okay, for your square. So you got all your diagonals just like that. Okay, so remember, when we do this on the test, you're going to do the Km. You're going to find the slope for that. So remember your slope formula for this one. The slope formula is M equals Y subset 2, Y subset 1 over your X subset 2 minus X subset 1. So again, you guys, it really doesn't matter which one you choose as your X1, Y1, X2, and Y2. It doesn't matter. Okay. Remember, what you are looking for after you finish that is the negated reciprocal. Okay, the negated reciprocal means the sign is different and it's flipped. So if you did the slope for this one here, let's just do that quickly. 2 minus -3, and then -4 minus -1. So that means you're going to get a negative and a negative, which is a positive. So that's going to give you 5. And then you're going to get a negative plus 1. So -4 plus 1 is going to give you a -3. Please don't get lost in the sauce. The slope for MKM is equal to -5/3. Okay, -5/3. That's how you write it. The negative is by itself, and then your fraction 5/3. The negated reciprocal means opposite sign. So the opposite sign of negative, of course, is positive. And remember, reciprocal means that you take the fraction and you flip it. Okay, so that means we're going to have 3/5. When you test the slope of your answer choices, the slope must be 3/5 for it to be the answer. All right. Excellent. 14. And all of this is in your notes, so this should not be the first time, shouldn't be the second time that you are seeing it. If it is your first time, then you probably were absent on the day that we did it, which you still need to make sure that you get your notes and make sure that you're asking questions. But if you're just not coming, then that's a whole separate thing. I don't know how to fix that. Okay? All right. So here we go. We've got angle ACD is what they're looking for, angle ABC, angle BAC, and angle ADC. Those are the 4 angles that we're looking for. So when we start this off, we end up here with a kite. We know the rules of a kite. Remember, the rules of the kite has only one pair of angles that are congruent. And we know that there's only one pair of angles that are congruent because of our rules, if we study the rules. The pair that's going to be congruent is here and here. So I'm going to call this X and call this X just like we did in our notes. And then I'm going to add all of these together. And when I add them all together, it's going to be equal to 360 degrees, because we know the sum of any 4-sided shape is 360 degrees. So from the jump, let's get that together. So 30 plus 60 plus X equals 360. I kind of ran out of room there. Please excuse that little balled up number. So we've got 90 plus 2X. I'll make it better right here. Given that 360, we get rid of the 90. And 2X is going to then equal 270. And then we'll divide the 270 by 2. Okay. So we've got that now. Remember, we need to identify where these angles are. So tracing this, tracing. Tracing A, C, D, we're not going to have right now, but tracing A, B, C, A, B, oh shoot, C. We know that that angle right there is going to be the 135. And then tracing ADC, this angle here is also going to be 135. Excuse me, y'all. All right. So then I got ACD. So I start off with A, and then I have to travel all the way down to C, creating that brand new diagonal that wasn't there, and then drop down to D. I'm looking for this here. Remember, to solve for this, all we're going to be doing is taking 60 and dividing it by 2, which is going to give us the answer of 30 degrees. We need to do the same exact thing for BAC. So we start off with B, we drop down to A, and then travel all the way out to C. And the angle that we're going to be looking for is right here. So that's going to be 30 divided by 2, and of course that'll be 15. And that's it, just like in your notes. Excuse me. Now, we got to remember, Isosceles Trapezoid has very, very special rules. So in the Isosceles Trapezoid, one thing that we know already is that H and E are going to be supplementary. So that means that angle H plus angle E is going to equal 180 degrees. And that's your jump off, okay? So you start here with 11x plus 20, and then plus 9x equals 180. Combine your like terms. Subtract your 20. 20x equals 160. So, of course, once you divide that into there, we should get 8, hopefully. They asked us for x, we got it. The other thing we have to remember about the isosceles trapezoid is that H is going to be congruent to O, because remember now your base angles are congruent to each other, okay? So angle H is congruent to angle O. Okay? So, first of all, we need to know how much angle H is. Okay? So that should be 88. And of course 88 plus 20 should go ahead and give us 108. Alright, so since we know that this is 108, all we have to do is set up for H, 108, and set it equal to O, which is 9m. And we divide. Okay. Easy division, we get 12. Alright, you guys, what we're going to be solving for here, B, X, Y, and Z. So what we're going to be doing is we're going to be setting up the problem. When we set this particular problem up, Remember that our base plus our base divided by 2 is our mid segment. Again, straight from your notes. It's not like you haven't seen this before. I cannot stress that. What I am seeing in class is that when I ask you to take out your notes, miraculously they have disappeared. They've been eaten by a dog, or I don't know. But whatever the case is, that is definitely a problem that you need to fix. Because I don't know how you're supposed to get a grade on your journal check if you don't have a journal, if you're not keeping up with your notes. So that is a problem. How are you supposed to be using the notes if you can't quickly get to them? You're thumbing through them in your book bag. We gave you a journal. What I mean, the school purchased the composition books, and I gave you one in the first week of school. If you wanted to use your own because it was pretty, good for you. But at this point in time of the year, the only thing that we're getting ready to do after I teach these next 2 sections is hit up this review. And you're going to need your journal, boo. All right? So B and B. First of all, we need to know what B, base and base. Here's a base, here's a base. Okay? So all we need to do is replace that. We're going to replace that with B, because that's a variable that we don't know, plus the 42 over the 2, and the mid segment is going to be 20. Okay, now we're doing this problem all the way through so you can see what is going to take place. All right, so anyway, we get an invisible 1 underneath that, and we cross multiply. B plus 42 is going to equal 40. Well, if I subtract 42 from 40, oh my goodness gracious, I'm going to end up with B equals -2. Now, this is a mistake because the length of a line cannot be -2, but if you follow the rules, that's what you should get, okay, is -2. I do apologize for that. This is an old standing question that I keep forgetting to fix, okay? I can tell you that on the exam, you should not have this problem. It will not be negative, all right? And again, remember that the distance from here to here has to be the same distance from here to here. So the distance on both of those is 22. Okay. All right. So here we go. We need to know the rules of the trapezoid. So remember, in the trapezoid, all of the angles are going to equal up to 360 degrees. But beyond that, our opposite angles don't mean a thing in this case. What we're going to be looking at is our consecutive angles. So consecutive angles are your back-to-back angles on each side. So starting off over here, I'm going to end up with Y and 81. Y and 81 are going to be your supplementary angles, meaning that they add up to 180 degrees. So to solve for the Y, all you have to do is Y plus 81 equals 180. Quick math. All right. Once you subtract that 81, of course, you should, of course, get 99. I hope everybody got that. Okay, that's the first thing. So let us jump over to the other side. So we got Y, we solved for B, we solved for Y. Let's jump over to the other side. We're doing the same thing. Remember, those two angles, angle B and angle C, are supplementary, meaning they add up to 180 degrees. So here I'm going to hit this up with 3 markings. 1, 2, 3. Man, that was probably the worst 3 markings I've ever made. And then hit this up 1, 2, 3, 4. That's much better. Anyway, these two are going to equal up to 180. So we're saying angle B plus 46 is equal up to 180. So again, all you're doing is subtracting the 46 from the other side. All right, so hopefully everybody was able to get that 134. All right. Now something very special happens when we have our mid-segment, which is PQ. PQ was the mid-segment. The mid-segment cuts the two trapezoids exactly in half, but what it does is the angle relationships are going to be the same. So it's like it's a dilation, like it shrunk down, but remember in your dilations, your angle measurements stay the same. Okay, so here in case in point, in the top trapezoid, the exact same numbers in the top left corner, in the top right corner, in the bottom right corner, and in the bottom left corner, left corner is going to be the same as the numbers down here, and then vice versa. So if this is 91, the bottom of this is going to still have to match up, because remember the rules of a trapezoid is that the angles, cover that up. Uh-oh. All right, that our consecutive angles are equal up to 180. So if this is 99 here, I know that P needs to be 81. Okay. Same thing on the other side. I'm going to hit that up with 4 markings. 1, 2, 3, 4. And I'm going to move this because I think that's messing up my, yeah. So remember the same thing. If this is 134 up here, then it's the same rule. These two angles must add up to 180 degrees. So if that's 134, then I know that this one down here would be 46. Okay. All right, so then we're going to have this angle here. All right, so this angle here is going to, of course, mimic the top. So we know that this is 99. And then we know that this one over here, 1, 2, 3, is 134. All right, it mirrors the top and the bottom matches up. Everything matches. So then that gives you your answer. We've got B, we've got Y, we've got X, we've got C. All right. In this one here, it asks for the perimeter. We're not going to prolong that. We know that the perimeter is adding up all of the sides. If by now we can't solve for the perimeter, well, we definitely need to make sure that we put that inside of our mind. It's just adding up all of the sides. Now, how do I know that all of the sides were 8? Because they all had the same marking. Okay, so that's how we would solve for that. All right. Now, for the area, I gave you a formula using the diagonal. This is not the only formula, but because they gave us a diagonal, this is the best formula for us to use to find the area. So the area of the rhombus is going to be D subset 1, which stands for, of course, diagonal 1, and then D subset 2. Remember, this dot in the middle means multiplication. Please don't lose that. Don't mess that up. Times divided by 2, and that's going to give you your answer for your area. Now let's go ahead and look at this, y'all. One, we already know what one of the diagonals is, and that's it. We need to get the other diagonal, so we need to connect the B and D to make that. All right, now that we connect that, remember what happens when we have diagonals in a rhombus. So inside of a rhombus, the diagonal is going to be not congruent, but they are going to bisect each other, meaning they cut each other in half. So if I know that the whole diagonal of AC is 14, of course, cutting it in half means that each one of these would be then 7. Okay. The other beautiful thing that happens is that right angles are created because they are perpendicular bisectors. Okay, so they are going to act as two lines that intersect that form a 90-degree angle. Now with that, what I want you to do is remove just one triangle, just like we did in our notes. I'm sorry, not our notes, but the last assignment. And put our right triangle. I know that over here my hypotenuse is 8. I know that my height is 7. And I know that down here at the bottom is what I'm trying to find. I'm trying to find a piece of the diagonal or half of the diagonal. In order to do this, I need to do a squared plus b squared equals c squared, and so that's what we're going to do here. Okay, so here's where you can make your mistake. If you do not put your 8 in the right place, is going to be wrong. Remember, your 8 is going to be your c squared. A and b is always interchangeable, and I have no cares in the world for which one you put first. Okay, remember this is a squared plus b squared equals c squared. We've been doing this since the beginning of the year. So 7 times 7 is going to give you 49. 8 times 8 is going to give you 64. Okay, we do that quick math right there. What are we at? 15. And then we do the square root of that, and I believe x gave us 3.9. Okay. So what does that mean? Nothing right now. We'll fill it into the picture. That means that x is 3.9, which is here. And if it's 3.9 here, we also know that it's 3.9 here. To solve for this, we need to multiply the diagonal and the diagonal and then divide by 2 right here into our formula. So here we go. We've got the diagonal, which is, one diagonal is 14. That was our original one. And we're going to multiply that by this. So remember, that's going to be 3.9 plus 3.9. So we'll have 7.8. And then we'll divide that by 2. Okay, so you'll have to put that in a calculator. And I'll do the same because I haven't looked at this number since earlier. So I can't remember off the top of my head exactly what it is. I cannot take the bad news right now. Alright, so we should get 54.6. Okay, so the perimeter would be 54.6. Okay. It doesn't say to round to the nearest tenth. It doesn't say to round to the nearest whatever. But because we round the other one to the nearest tenth down here, that's why we're rounding this to the nearest tenth. On the test, the instructions will be much clearer. If we need to round, it'll tell us. But I believe all of the numbers, even when we do the a squared plus b squared equals c squared, should come out as a whole number, if I remember correctly. Okay. Alright, so as you can see, this was an error. This does say that it's solved for b, x, y, and z, and as you can see in the picture, there's no b, x, y, and z, so of course you can't solve for that. So come on, class. Let's see what we need to solve for, which is c, a, b, and d. Okay? Alright, so in this case, we got to look at the picture and see that we have two shapes that we're dealing with. One is a kite, and the other one is the isosceles trapezoid. And we cannot deal with the isosceles trapezoid until we deal with the kite, because the kite is the key to opening up the trapezoid. Okay, some kind of way, if I was a rapper, I would make some kind of lyrics with that, but whatever. So now that we have that, now cover this up like so, to only look at the kite. Alright, and the reason why I want to do that is because remember in our kite we have some rules. Opposite angles are going to be congruent. There's only one pair of opposite angles here that match that, and that means that this is going to be 123. Now, to get C, remember this whole entire shape, the sum of all four of the angles equals 360 degrees. So we need to do that math, that 123 plus the 123, and this is just like in your notes, plus the 38 plus C equals 360. Okay, so if you haven't done that math, please make sure that you have done it. So C should equal 76. Okay, and we've got one of the answers, which is C. The immediate thing we need to do is jump down to the trapezoid. If you notice, there is a marking on angle 123 in the kite. When we look at the trapezoid, oh my goodness, there is the same marking down there. So that means that D, oh my goodness, that means that D is going to equal 123. Okay. Now remember, in the isosceles trapezoid, your base angles are congruent. Remember, there are two pair of base angles. So if D is 123, that means that B is 123. And in this case, we've got B and A. Remember, in a trapezoid, these are also consecutive angles. And the consecutive angles, you guys, are supplementary. Meaning that angle A plus angle B, or A and B, should equal 180 degrees. So we don't know A, but we know B. All right. And then we should get our answer for that. Everybody good? No, nobody's here. Sorry. All right. The very last one that we want to do is plot the points here. And remember, don't get lost in the sauce. Okay? Don't get lost in the sauce. Start off with the negative 3, 3, 1, 2, 3, 1, 2, 3. More people is going on to heaven. And 1, 2, and then 1, 2. That's your B. And then 1, and then negative 3, 1, 2, 3. Which is C. And then negative 4, 1, 2, 3, 4. And then down to 1, 2. Now you always want to go back and check your work to make sure that you put your points in the right place. Sometimes it's very easy to mess it up. Read an X as a Y or Y as an X. Put it on the negative side when it's positive. Remember, I told you need to find the length of the side. So let's go ahead and do that and not waste any time. Okay. Jeez. A little too far up on that. So that's 1. And when we count from here, 1, 2, 3, 4, 5. Drop this down here. That's 1. 1, 2, 3, 4, 5. So we know that these two sides are the same. It's coming along quite nice. Here we go. We got 1 and 5. And 1 and 5. So already we know that all 4 of our sides are going to be the same. When the sides are the same, that's two shapes that operate that way, the rhombus and the square. In order for us to make a good choice between the rhombus and the square, we need to test the diagonals just like we did in our notes. Okay? So when I mean test the diagonals, we need to also find the length. So I'm going to create a right triangle for my diagonal and count. Okay, so what am I counting? I'm counting these boxes. 1, 2, 3, 4, 5, 6. And then I'm counting over here. 1, 2, 3, 4. Okay, so I know that the first diagonal is 6 and 4. Let's test the second diagonal. Now notice I'm not running the slope formula. I'm not running the distance formula either. And the reason why is because if we can do it using our pencil and just counting the sides, then we'll be good to go. That lets us know that it's congruent. However, the moment the numbers change, we need to go ahead and put it into the formula to see if it still works out. Okay? Second diagonal. Okay? So again, let's count. I'll start up here since that's where my pencil still is. 1, 2, 3, 4. So that gives me 4 here. And then down 1, 2, 3, 4. Oh, did I count too many? Sorry. 1, 2, 3, 4, 5, 6. Okay, so we're at 6 on this line. So it's the same 4 and 6 on the other. So the diagonals are congruent as well. Because the diagonals are congruent, because the sides are congruent, it is a square. Well, it's been real, y'all. I'm tired. I'm going to bed after I post this video. Hopefully it'll load to YouTube in a timely manner. Please remember, in class tomorrow, any additional questions you might have, please make sure you ask. And then also we'll be working on another assignment that'll be practice problems during class. So please make sure that you get those in as well. Best of luck. Test is going to be on Monday. Monday. So please take the weekend to study as well. And we're looking for all greens and a couple of yellows. And that's all I have. And that's on Mary Had a Little Lamb.